Oh, I see you, looking at that red squiggly line, that complex nested object from an unknown API. You are tempted. It's right there. Any. We've all done it. It's the TypeScript get out of jail free card. But we know the truth. Using any isn't writing TypeScript. It's writing JavaScript with extra steps and guaranteed runtime bugs tomorrow. Today, we are staging an intervention. We are putting down the any stamp and adopting 5 elite TypeScript patterns that seniors use to handle uncertainty without surrendering type safety. Welcome back to Elite Tech Club. Let's make your types bulletproof. The problem with any is that it doesn't just describe unknown data. It actively tells the TypeScript compiler to shut up and stop checking this variable. It is a security breach in your codebase. A senior dev knows that uncertainty is inevitable, but safety is mandatory. We need patterns that say, I don't know what this data is yet, but I promise to verify it before I use it. Let's look at the first alternative. Pattern number 1 is a direct replacement for any, the unknown type. Imagine we are fetching a configuration object from a third-party API. We really don't know the shape. Let's start with the junior way. Here we've got a function, process config, which takes a parameter API response. As mentioned, we don't know the shape and it is of type any. Here we just want to log API response dot database dot host dot to uppercase, something like that. TypeScript assumes these exist until runtime crashes. So here we don't get any warnings, any errors, not at all. This code might work today and it might explode tomorrow. The any type wide opens the door for errors. Now let's make it elite. We change any to unknown. Okay, so I copy these lines and comment out these. And here the senior way, this time I change any to unknown. And you see that we immediately get these red line under the API response. And this is a compile error. If we hover over API response, it says API response is of type unknown. So we can't even run our code because this is a compile error. See that? The code immediately breaks. Why? Because TypeScript is protecting you. It says you cannot access anything on unknown data until you prove what it is. This forces us to use pattern 2. Pattern 2, type narrowing. This is how we utilize unknown data. We verify its shape before accessing properties. We need to narrow the possibility from anything to specifically this object shape. Let's do it. First of all, let's define an interface. Interface db config, which has a nested database object. And inside of that database, we've got host, which is a string. Cool. Now we need a user-defined type guard. This is a function which returns something similar to a boolean, but it's not actually a boolean. I'll come back to that in a moment. It's a type predicate, but let's see it together. So function is db config. In the end, we want to ensure whether that API response is a db config or not. Then API response, or maybe object obj, which is of type any, and this is the important part. It returns obj is db config. And yeah, we see this red line because it's not returning anything. Let me finish that and then I'll explain it to you. Returns database in obj and host in obj.database, and I save it. So this is standard JavaScript code. Here we are checking if database property exists on object, and here we are checking if host exists inside the obj.database object. Here is the important part, as we said. So the type predicate. Now there's a small difference compared to a boolean. A boolean in the end is true or false. Here, if our function returns true, this object will be narrowed down to dbconfig. If this function returns true, you can officially treat obj as a dbconfig interface from now on. Let me also add a comment here, check if the shape matches our interface. I mean, the dbconfig interface, of course. Okay, now we write the process config function. Process config, which takes API response as the parameter of type unknown. And here we need an if check. If is dbconfig, and we pass this API response to that. So if this object shape matches dbconfig interface, here let me write TypeScript is happy here. We can securely write anything, so we can access the nested object and finally the host. So API response.database.host.to uppercase. You see, the IDE doesn't complain. And of course, we can have an else statement. Else console.log error invalid API response shape. Cool. And let's call this function process config. Let me first declare a variable, an object, const response, just to check whether it works. And then database, inside of that we got host and test, doesn't matter. This function needs an argument. I'll pass response and I save it. You see that test has been printed here, so it's working. If I change that, so for example, I remove this host and add, I don't know, something else, ID for example, or just make a change and then I save it, you see that now we get this error, invalid API response shape. So it's working as expected. Look at that. It reads like a sequence. If the API response passes our custom check, TypeScript unlocks the properties and we can use them safely. It's like checking ID at the door. We don't let just any old data vendor in. Pattern 3. Stop using any for generic functions. If you have a function that processes an item and you don't care what that item is, don't use any. Use a generic type. Let's create a simple function that logs a piece of data and returns it. The junior way is this tragedy. Okay, so we've got a function, log and return, takes a parameter, data, which is of type any, and then returns any. This is very simple. Console.log processing, and we concatenate that with that data, and finally we return it. Very simple. Then I declare two constants, num, we call log and return, and we pass, for example, 61, and then another constant, str, log and return. Here we pass a string, for example, hello. Now, yeah, you see the result here. The thing is that this num, as you can see, and also str, both are of type any. So there's no way to distinguish between these two. We've lost all type safety. The compiler thinks num is a string and str is a number. Let's refactor it to edit. I'll copy this line and also, oops, I'll comment out these lines. I paste it here, and here using angle brackets, I declare a generic type. So type T, and here this data is also of type T, and same for the return type. So here this angle brackets together with an uppercase letter in between preserves the type. So TypeScript in the end can infer that. Perfect. By using the T inside angle brackets placeholder, we preserve the original type. TypeScript looks at what you passed in and knows that the result is also that exact same type. Flexibility with 100% safety. Pattern 4. Replace string or number with union types. If a variable should only hold specific values, define them. Juniors allow the world into their variables. Seniors set a budget. Let's look at setting a button state. Here I declare a type button status, which is either string or any. And this is a mistake some beginners make. So when you use the union operator between any and another type, that type becomes completely meaningless because any actually covers everything. So it's like saying I will drink a glass of water or any other liquid in the world, you know? It doesn't really make sense. Let's declare another variable, button status, which is of type button status with capital B. Initially it's loading, then I can also set it to everything. So button status success, button status hamburger, even button status 23. So because of this any, we are not protecting it at all. So we can set it to everything actually. If you only need 5 specific statuses, use string literal unions. It's also the case for button status. So here, first I commented out the previous lines. Again, we can have button status, and this time we know that it's either loading or success or error or default. Then I declare a variable let button status, which is of type button status, and I set it initially to loading. You see that even the IDE is suggesting one of those 4 values, and I cannot assign any other value. So for example, hamburger here, you see that I get this red line and says type hamburger is not assignable to type button status because we explicitly mentioned that you're only allowed to have one of these 4 values. One line. If the variable is not one of our allowed values, TypeScript immediately creates an error. It's self-documenting and bulletproof. Finally, the hidden gem of modern TypeScript in 2026, the Satisfies operator. This pattern lets you validate an object's shape without widening its type. Let's say we have a color palette object. We want to ensure all the keys are valid color names, but we also want to preserve the specific hex values. So here I declare the type color, which is either red or blue or green. Then I declare a constant palette1, which is a record of color and string. And I forgot the assignment operator. So if I hover over this, you see that it's mentioning type empty object is missing the following properties from type, record, color, and string, and it's mentioning red, blue, and green. So far so good. So I start to add them. Red is FF0000, and then blue again. Here if I hover over this, you see that it's saying property green is missing, so it's working as expected. Green, perfect. So here we are validating the shape using this record, but it's widening the type. So for example, this value is a string and not a specific hex value. So if we want to, for example, pass it to a function, then we might get errors. We can do better with satisfies. So I copy these lines, constant palette 2, I remove this part, but here I write satisfies, and now record, color, and string, and then I save it. Now, for example, palette2.red is specifically this value, and it's not a random string, you know, and we preserve the exact inferred type while validating the shape. Just one more thing to add here: to freeze these values, we need to add as const to the second color palette. And now to see the difference, I prepared a very simple function. Let's see. So here there's a very simple function without a body actually. Set background to red, and we've got a parameter, and then here first we call it with palette1, so the standard annotation, and then with the second one, which is using satisfies. So for the first one, if I hover over this, you see that we get the error: argument of type string is not assignable to parameter of type the hex code for red color. And in the second one, we don't get any error because it knows that this palette2.red is specifically equal to this value. Look at that beauty. Satisfies ensures we didn't miss a color name, but it allows TypeScript to continue inferring the exact specific hex value of palette2.red. It's the perfect blend of validation and inference. It is so clean. There you have it. 5 patterns that show the world you aren't just trying to make the compiler shut up. You are actively using types to prevent bugs. It's the time for the elite scorecard. Which of these patterns was new to you? Are you still stamping any on your complex objects? Let me know in the comments. I promise I won't judge much. If you want to level up your programming skills, hit that subscribe button and turn on the notifications so you don't miss my next videos. Until next time, keep coding, keep learning, and as always, stay awesome.